Hello everyone. Let's start with a quirky thought. Have you ever tried pushing a wall with all your strength? No matter how hard you push, the wall pushes you back with equals to bonus. The result? You get tired, but the wall stands tall, smiling at you. This is Newton's third law of motion. For every action, there is an equal and opposite reaction. The two forces are equal in size, opposite in direction, and, very important, they act on different bodies. That's why they don't cancel each other. So remember, every push has a pushback, every pull has a pullback. Forces are like dance partners, they always come in pairs. To see this law in action, let's use a simple experiment. Take two spring balances tied together with one end fixed to a wall. Now pull one balance. Both balances show the same reading. Why? Because the pull from one balance is matched by an equal pull from the other. In physics words, force A equals force B, but in opposite directions. As shown in the textbook diagram, both balances stretch equally. It's like a tug-of-war where neither side wins because action and reaction are perfectly matched. Now let's step into daily life, literally. When you walk, your foot pushes the ground backward. That's the action. The ground pushes your foot forward with equal and opposite force. That's the reaction. And voila, you move forward. Swimming works the same way. You push water backward and water pushes you forward. Rowing a boat. The oar pushes water back and the water propels the boat forward. Without Newton's third law, we couldn't walk, swim, or row. We'd all just be stuck in place, helpless, like cartoons running on the spot. Let's raise the drama. Imagine firing a gun. The bullet rushes forward, but at the same time, the gun jerks backward. That's recoil. Here's why. The gun exerts a forward force on the bullet. The bullet exerts an equal and opposite backward force on the gun. But the bullet has tiny mass and gains huge velocity. The gun has large mass, so it moves back only a little. Same force, very different results. Another classic example, a sailor jumps forward off a boat. The boat drifts backward. Action, sailor pushes boat. Reaction, boat pushes sailor. Equal forces, opposite effects, because their masses are so different. Sports are full of Newton's third law moments. When two football players collide, both feel the impact equally, out for both. In cricket, when the bat hits the bat pushes the ball forward and the ball pushes back on the bat. That's why bats sometimes sting in the hands. In gymnastics, when an athlete pushes the ground hard, the ground pushes them upward with equal force, helping them flip and soar. So whether it's football tackles, cricket shots, or gymnastics jumps, action and reaction make sports exciting and sometimes painful. Let's solve a numerical to seal the idea. Suppose a bullet of mass 0.02 kilograms is fired with velocity 400 meters per second. The gun's mass is 5 kilograms. What will be the recoil velocity of the gun? We use conservation of momentum, mass of bullet times velocity of bullet plus mass of gun times velocity of gun equals 0. Substitute 0.02 times 400 plus 5 times velocity of gun equals 0. That's 8 plus 5 times velocity of gun equals 0. So velocity of gun equals negative 1.6 meters per second. The negative sign simply means the gun recoils in the opposite direction to the bullet's motion. This shows recoil is unavoidable. The bullet races forward and the gun is pushed back in response, exactly as Newton's third law predicts. Let's wrap it all up. Newton's third law says, to every action, there is an equal and opposite reaction. Forces always occur in pairs. They never cancel because they act on different objects. This law explains why we can walk, swim, and row, why guns recoil, why boats drift when sailors jump, and why collisions in sports feel equally strong to both players. The crux: equal forces, opposite directions. The effects differ only because masses are different. So next time you push a wall, catch a cricket ball, or watch a gymnast launch into the air, remember, action and reaction are quietly at work, balancing the universe. I hope you're now confident enough to explain Newton's third law to anyone, even during a football match or a boat ride. See you in the next session, where we'll connect this law to the grand principle of momentum conservation.